Welcome to Naradar Academy. In this video, we are going to discuss about how to find the reduction formula for powers of trigonometric functions. That is, this video is going to cover the procedure for finding reduction formula for sine power nx, cos power nx, and the product sine power px into cos power qx, secant power nx, tan power nx, cosecant power nx, and cot power nx. So around 10 reduction formula derivations we are going to see. Problems I will cover in a different video. Okay, so just the procedure and the formula, how to find the formula, that is the thing we are going to discuss in this video. So the first one is for finding the reduction formula for integration of sine power nx, where n is a positive integer. Okay, let us take the given integral as in. I for integral, n for the power. Okay, in is equal to integral sine power nx dx. Okay, in integration you have standard formulas, a set of standard formulas. Apart from the standard formulas, if you have a product of two functions, you have a formula called integration by parts. This is the formula that we use for integration by parts. In that one, you take some variable, some function as u and the remaining function as dv, and we use the formula like this: integral u dv equal to uv minus integral v du. So this is the formula we use when we have product of two functions within the integrand, isn't it? So but here you see we have sine power nx. This we cannot do integration directly as it is. Okay, so I have to apply integration by parts. But for applying integration by parts, I am having only one function here, no, sine power nx. So for applying this formula, I am going to split this sine power nx as sine power n minus 1x into sine power 1x dx. Okay, power n is split into two parts. One is n minus 1, another one is 1. So that together the product will become sine power nx dx. Isn't it? Now you take this as u. U is equal to sine power n minus 1x. And this one is there, no, sin x dx. Thus you take dv. So u dv we have. This is the formula. So for this formula we have to differentiate this and find du and integrate this and you find v. Okay, differentiation of u. So du is equal to, see, this is sine power n minus 1x, no. So what will be the differentiation? N minus 1 into sine power n minus 2x into differentiation of sin x is what? Cos x dx. Chain rule I am applying. Okay. Differentiation of sine power n minus 1x is n minus 1 into sine power n minus 2x into what is differentiation of sine? Cos x dx. So chain rule I am applying. Okay. Next, this is dv. Sin x dx is my dv. Integrate it and get v. So v is equal to integration of sin x is what? Minus cos x. What's the formula? uv minus integral v du. So uv, what is uv? Minus cos x into sine power n minus 1x minus v into du. Already one minus is there, no? So it will become plus cos x into n minus 1 sine power n minus 2x into cos x dx. So this term will remain the same throughout the simplification. Let us concentrate only on this integral. So here take n minus 1 outside. So sine power n minus 2x into cos square x dx. See, every time we do integration, whenever you take this u and dv, the selection of this u and dv plays a crucial role in integration by parts. Okay, how you have to choose this u and dv? In ordinary problems, you choose u as the function which on successive differentiation will give 0. Okay, that is which function, which of the integrand which will give you 0 by successive differentiation, that is taken to be u. The remaining function is taken to be dv. But here the problem with this question is, here my integrand is sine power nx. So how many times you differentiate, it will never become 0. So what I am doing is just at least I am trying to reduce the power of the function. Power n is there, no? So every time I am trying to reduce the power. Okay, now you see this integrand here, my power of sine reduced to n minus 2. But here one more function is appearing, cos. This is not related to this integral. So what I am going to do is I am going to rewrite in terms of sine. Okay, so sine power n minus 2x into, instead of cos square x, I am writing 1 minus sine square x. Then you multiply. So I am getting n minus 1 into sine power n minus 2x dx. Okay, here dx minus The next one is n minus 1 into integral sine power nx into dx. Okay, this is nothing but the integral with the power n minus 2. This is the same integral with the power n. So this can be written as n plus n minus 1 into I n minus 2, and this is n minus 1 into I n. Okay, so my in is equal to minus cos x sine power n minus 1x plus n minus 1 I n minus 2 minus n minus 1 into in. Okay, bring all in to the left side. Okay, so in into 1 plus n minus 1 in is equal to minus cos x into sine power n minus 1x plus n minus 1 into in minus 2. Now you take in outside, it will be 1 plus n minus 1. So simply it will be n. Then throughout divide by n. So in equal to minus 1 by n cos x sine power n minus 1x plus n minus 1 by n into in minus 2. Okay, this is called the reduction formula for sine power nx. Why this is called reduction formula? Because in each step of integration we are reducing the power of the integrand. Okay, right? That you have to ensure whether it is getting reduced or not, because sometimes you may get it to get increased, but that you should avoid it. Okay, right? Now the next problem is, see, this is the most general integral I have done here, but most of the problems you will have with limits from 0 to pi by 2. So how to evaluate integral 0 to pi by 2 sine power nx dx? This is somehow simpler than the previous one. Okay, the previous one without limits they have given, here the limits are given. So let me take this to be in equal to integral 0 to pi by 2 sine nx dx. So previously I have derived one result. No, that result I am going to take along with the limits. So what is the first line? Minus 1 by n cos x sine power n minus 1x within the limit 0 to pi by 2 plus n minus 1 by n into I n minus 2. I have written there, no, that I n minus 2 simply you can write. Okay, right. Now when you apply the limit, see, cos, when you apply pi by 2 upper limit, cos will become 0. So the entire term will become 0. And when you apply the lower limit, sin 0 will be 0. So the first part will be 0 always. So simply what you have, in equal to n minus 1 by n into in minus 2. So this is the reduction formula for this. See how simple term this is. Okay, but continuously you have to find the values for in minus 2, in minus 4, etc., and substitute them all together in this term. So this is in equal to what? N minus 1 reduce by 1 and then n minus 1 by n into in minus 2. So this in minus 2 I have to find out, no, what will be in minus 2? The same formula you substitute. For n minus 2 it will be what? N minus 3 by n minus 2 in minus 4. Next, what will be in minus 4? In minus 4 will be n minus 5 by n minus 4 into in minus 6, and so on, etc. See, in each term the index are reduced to 2 by 2. That is, initially my index is n, then in the next step it is reduced by 2, in minus 2, next n minus 4, n minus 6. It is reducing 2 by 2. So depending on the value of n, either it will reduce to I3 or I2. That is, when n is an odd integer, it will finally end at I3. When n is an even integer, it will end at I2. Okay, so let us find what is I3 and I2. So what will be I3? For that you substitute in this formula. I3 equal to 3 minus 1 is what? 2. 2 by 3 into I1. Okay, so 2 by 3 into I1. This I1 I want to evaluate. So I1 equal to integral 0 to pi by 2. I have to, for finding I1, I have to go to the original question, because this formula cannot be applied for I1, because this will be what? I minus 1 it will become, no, so it's not applicable. So for finding I1, you take the question. So I1 equal to integral 0 to pi by 2 sin x dx. So equal to, in what is integration of sine? Minus cos x within the limit 0 to pi by 2. Okay, right? So you apply the limits. Cos pi by 2 is 0. Sorry, cos pi by 2 is 0. The lower limit cos 0 is equal to 1. So simply I1 equal to 1. If you put I1 equal to 1, this will be what? 2 by 3. I3 equal to 2 by 3. So consolidate all the results, and I can write in is equal to, so in how to write? N minus 1 by n into n minus 3 by n minus 2 into n minus 5 by n minus 4, etc. into what will be the last term? 2 by 3. When n is an odd integer. Suppose when n is an even integer, it will finally end up at 2. I2 equal to, I2 how to find? Here you put 2. 2 minus 1 is 1. 1 by 2 into I0. I0 means you have to evaluate from the given question. I0 equal to integral 0 to pi by 2 sin power 0x dx. Anything power 0 is what? 1. Okay, integration of 1 dx is x within the limit 0 to pi by 2. So the answer is what? 1 by 2 into pi by 2. What is the value of I2? 1 by 2 into pi by 2. So my In will become n minus 1 by n into n minus 3 by n minus 2 into n minus 5 by n minus 4, etc. The last term is 1 by 2 into pi by 2. Okay, so let me consolidate. So the reduction formula for integral 0 to pi by 2 sine power nx dx is equal to, numerator will be reducing 1 by 1, n minus 1, n minus 3, n minus 5, etc. And denominator will be n minus 2, n minus 4, etc. If n is an odd number, it ends up at 2 by 3. If n is an even number, it ends at 1 by 2 into this pi by 2 you have to write. Okay, whatever you get, that will be 1 by 2 only. If n is an even integer, you will arrive at 1 by 2 automatically, but you have to multiply that value by pi by 2, right? Okay, then next one is, we are going to find the reduction formula for integral cos x power n dx, where n is a positive integer. This is exactly similar to what we did the procedure for integration of sin x power n dx. The same thing I am going to do here. So for integrating this function, I am going to split it as power of n minus 1 into power 1. So cos power n minus 1 x into cos x dx. Let me take this as u and this as my dv. So u equal to cos x power n minus 1 and dv equal to cos x dx. So what will be du? Differentiation of this one is n minus 1 into cos x power n minus 2 into differentiation of cos is what? Minus sign. Chain rule I am applying here. Minus sin x into dx. Next, integration of this, v equal to integration of cos x is sin x. What's the formula for integration by parts? uv minus integral v du. So you substitute. So it will be what? Cos x power n minus 1 into sin x minus integral v into du. Already here one minus is there, no? So it will be plus integral sin x into n minus 1 cos power n minus 2x into sin x dx. So the first term is going to be the same throughout the simplification. Let me concentrate only on this integral. As before the previous result, keep n minus 1 outside. This is cos power n minus 2 and this is sin square x. So at every step you should concentrate only on reducing the power of cos. Don't bring any other term inside the integral. Okay. So I want to change this sign into cos, so that I am writing as 1 minus cos square x dx. Then you multiply. It will be integral cos power n minus 2x dx. Another one is integral cos power nx dx, right? Okay, so in equal to cos power n minus 1x sin x plus n minus 1 into, this is what, I n minus 2 minus n minus 1 into in. Bring all the in terms to the left side. So what I am getting, in equal to n equal to cos power n minus 1x into sin x plus n minus 1 into in minus 2. And finally, in equal to 1 by n into cos power n minus 1x sin x plus n minus 1 by n into in minus 2. Next, let's see what will happen if we put the limit 0 to pi by 2. Okay, so for this one, again you take the given integral to be in equal to integral 0 to pi by 2 cos power nx dx. So from the previous result, I have taken in equal to 1 by n cos power n minus 1 x into sin x. Now you apply the limits plus n minus 1 by n into in minus 2, no? So you keep in minus 2 as it is. Now if you see here, the upper limit, when you apply pi by 2, cos will become 0. When you apply the lower limit, sin will become 0. So the entire term reduced to 0. So simply what you have, in equal to n minus 1 by n into in minus 2. So again the same thing as for sin function. What will be in minus 2? It will be n minus 3 by n minus 2 into in minus 4. What will be in minus 4? N minus 5 by n minus 4 into in minus 6 and so on. So it is reducing 2 by 2. The index is reducing 2 by 2. So finally, where will you arrive at? If it is an odd integer, the last term will be I3. If it's an even integer, I2 will be the last term. So I3 equal to, you consider this one, I3 equal to 3 minus 1 is what? 2 by 3 into I1. Okay, right? So equal to 2 by 3 into, for evaluating I1, you should not take this, okay, because if you put 1, it will be I minus 1. So that's not possible. So for finding I1, you have to take the question, right? So I1 equal to integral 0 to pi by 2 cos x dx. Integration of cos is what? Sin x. So you substitute the limits, it's simply I3 equal to 2 by 3. Okay, so what will be the reduction formula? N minus 1 by n into n minus 3 by n minus 2 into n minus 5 by n minus 4, etc. up to the final term will be what? 2 by 3 when n is an odd integer. Next, when n is an even integer, it will end up at I2. Okay, so for finding I2, take this formula, I2 equal to 1 by 2 into I naught. For finding I naught, this formula is not applicable. So you have to go to the question. So here if you put 0, it will become what? Cos power 0x dx. Cos power 0, anything power 0 is 1 now. So integral 1 dx. So that is x within the limit 0 to pi by 2. So the answer is what? 1 by 2 into pi by 2. So when n is an even integer, the formula is n minus 1 by n into n minus 3 by n minus 2 into n minus 5 by n minus 4 etc. up to the final term is what? 1 by 2 into pi by 2. Okay, so I have consolidated the result here. Integral 0 to pi by 2 cos power nx dx is equal to n minus 1, n minus 3, n minus 5 in the numerator, and denominator is what? N minus 2, n minus 4 etc. If n is an odd integer, it ends up at 2 by 3. If n is an even integer, it will end up at 1 by 2. Multiply it again by pi by 2. If you look at the formulas for both sin power nx and cos power nx, they will be the same. Okay, right, that's the beauty. So you a single formula is enough for doing the problems for both sine and cosine function. Next, so individually we have seen the reduction formula for sine theta and cos theta. Now we are going to see the product. Okay, sine power px into cos power qx dx, where both pq are positive integers. So let me take this as my IPQ. IPQ equal to integral sine power px into cos power qx dx. Right. So again, for doing integration, now I am having two functions. Previously what I tell you, that is for doing integration we are going to make use of integration by parts. For doing that we need two terms, product of two terms. That is why we split the sine power n or cos power n, whatever it may be. In the previous two problems I have discussed in that way only, but now in the question itself you are having product of two things, but we cannot keep them, we cannot take them as it is, because if I take one as u, another one as dv, I cannot do the integration. Okay, right, so that is not possible. So for that what I am doing is, as like the previous case, keep cos power qx as it is. Sin power p you split into two parts, sin power p minus 1x into sin x dx. Okay, now let u equal to sin power p minus 1x and dv equal to cos power qx into sin x dx. Okay, now let me find du equal to, as before the previous problems, it will be p minus 1 into sin power p minus 2x into integration of sin is what? Cos x dx. So here I have applied chain rule, so I find out what is du. Now let us come to dv. dv equal to cos power qx into sin x dx. See, let me explain you. See, integration of x power n dx is equal to x power n plus 1 by n plus 1, isn't it? That is, this is formula is true only when both the functions are same, otherwise this formula is not applicable. So here cos power q you have, but here what you have? Dx, no? So this should be what? D of differentiation of, in here dx you have, no? So d of cos x should be there. D of cos x means what? Sin x dx. So this sin x dx I am going to write it as what? D of minus cos x. Okay, that is why I have split this sin power p minus 1 into sin x into dx. Otherwise simply if you take cos power q as your dv, this process cannot be applied. There will be no change in u. Okay, even if you take sin power px, that won't do any harm. Only for integration you won't get it in the correct form. So for the purpose of integration only I have taken sin p minus 1 into sin x. Okay, now this you can rewrite it as minus into minus. Okay, so minus cos power qx into differentiation of minus cos x. Now this takes this form, integration of x power n into dx. What's the formula? X power n plus 1 by n plus 1. So simply integration of this one will become minus cos power q plus 1 x by q plus 1. Okay, so now you know what is u and v. Now you substitute. So IPQ equal to sin power p minus uv, isn't it? No. So minus sin power, this is p minus 1 only. Okay, that is u only we are writing, no? Sin power p minus 1 x into cos power q plus 1 x by q plus 1 minus integral v du. So already one minus is there, so it will be plus integral cos power q plus 1 x by q plus 1 into p minus 1 sin power p minus 2 x into cos x dx. So it will be minus 1 by q plus 1 into sin power p minus 1 x into cos power q plus 1 x. There will be no change in the first term throughout the simplification. So let us keep it as it is. Let us concentrate only on this integral. So p minus 1 by q plus 1 you can take outside. So within the integral you have sine power p minus 2x into cos power q plus 2x into dx. See, every time I am telling you the purpose of doing reduction formula is to reduce the powers of the integrand, isn't it? So here sine is power p and cos power is q. But here you see the power of cos get increased, no, q plus 2. At least you can retain the same power, but you cannot get it increased. Okay, so instead of this cos power q plus 2, let us rewrite it as cos power q into cos square, so that this cos square can be rewritten as 1 minus sine square. Okay, now this cos square is rewritten as 1 minus sine square. Now you multiply the terms. So p minus 1 by q plus 1 into integral sine power p minus 2 into cos power qx minus integral sine power, this will become what? Sine power p into cos power qx dx. So this is my I p minus 2 comma q and this is my I p q. Okay, bring all the I p q to one side. Okay, so what will you get? I p q plus, see, I p q plus p minus 1 by q plus 1 into I p q is equal to minus 1 by q plus 1 into sine power p minus 1x cos power q plus 1x plus p minus 1 by q plus 1 into I p minus 2 comma q. Now you simplify the left hand side. So simply what will you get? 1 get cancelled. P plus q by q plus 1. No. Throughout in the denominator you have q plus 1 as a common factor. So divide. So in the numerator you have p plus q. So bring that p plus q to the right hand side. So IPQ is equal to minus 1 by p plus q into sine power p minus 1 cos power q plus 1x plus p minus 1 by p plus q into IP minus 2q. Okay, so this is the reduction formula for sine power p into cos power qx. See here, in the beginning, you know, I have reduced the power of sine. In the same way, you can keep sine as it is and reduce the power of cos. Okay, a slight difference will be there in the final formula. Okay, right. Next one is limit with the limit 0 to pi by 2 sine power px into cos power qx dx. Let IPQ is equal to the given integral. Now I have derived the formula for without limits. So let me take this formula and apply the limits. Minus 1 by p plus q into sine power p minus 1 cos power q plus 1x within the limit 0 to pi by 2 plus p minus 1 by p plus q into I p minus 2 comma q. Now when you apply the limits, as usual the first term will become 0, only this term will come. So IPQ equal to p minus 1 by p plus q into IP minus 2 comma q. So now you find what is IP minus 2 comma q. So here we are reducing only the index p, q is kept as it is, right? In the same way you can keep p as fixed and reduce q. Okay, now see, IP minus 2 comma q is equal to p minus 3 by p plus q minus 2 IP minus 4 comma q. Similarly p minus 4, so q is kept constant everywhere, only p is getting reduced 2 by 2. So p minus 4 comma q is equal to p minus 5 by p plus q minus 2 IP minus 6 comma q, etc. So this will end at I3 comma q when p is an odd number. When p is an even number, it will end at I2 comma q. So let us discuss one by one. For I3 comma q, it will be, take this result, put p equal to 3. So 2 by 3 plus q into I1 comma q. So for finding I1 comma q, we have to take it from the question. Okay, so I1 comma q is what? Integral 0 to pi by 2 sine power 1x into cos power qx. So it is simply what? Cos power qx into the sin x dx. How can you write? Differentiation of cos x. So this will be minus cos power q plus 1x by q plus 1 within the limit 0 to pi by 2. So upper limit will become 0. Only for lower limit it will be 1 by q plus 1. So it will be 1 by q plus 1. I1 comma q will be what? 1 by q plus 1. Similarly, when p is an even integer, this process will end at I2 comma q. For I2 comma q, it will be 1 by 2 plus q into I0 comma q. For finding I0 comma q, go to the question. So I0 means what? Sine power 0 into cos power qx. But integral 0 to pi by 2 cos qx, for this we have reduction formula, and the reduction formula takes two different forms. When q is an odd number, this will be the reduction formula. When q is an even number, this is the reduction formula. So two different forms we have. Okay, right. So consolidating all these things, what will you have? IPQ is equal to, when p is an odd number, single formula, p minus 1, p minus 3, p minus 5, etc. up to 2, p plus q minus 2, etc. up to q plus 3 into 1 by q plus 1. When p is an odd number, Q may be anything. You can remember like this, when for individual sine and cos function, when n is an odd integer, what will you write? It ends up at 2, no? Here it ends up at 2 by q plus 3, and extra 1 by q plus 1 term you have to add. When p is an even number, two different cases arise. When p is even and q is odd, it will be what? P minus 1, p minus 3, p minus 5, etc. up to 1. In the denominator will be p plus q minus 2, etc. up to q plus 2 into q minus 1, q minus 3, etc. up to 2 by 3. Because q is odd number, no? So it ends up at 3. So when p is even, you have to write separate formula for q also. And when both p and q are even, write the same thing, p minus 1, p minus 3, p minus 5, etc. up to 1 by p plus q minus 2, etc. q plus 2 into. For q even, it will take the form q minus 1, q minus 3, etc. up to 1, q minus 2, etc. up to 2 into pi by 2. Okay, right. Next one is tan power nx, where n is a positive integer. Let in is equal to integral tan power nx dx. Okay, now see, differentiation of tan x is what? Secant square x. So for sine and cos, we reduce the power as 1 and you take udv method. But for tan and cot, you have to reduce the power by 2. Then only you can get the correct form for doing integration by parts. So let me write tan power n minus 2x into tan square x dx. Then this tan square x can be rewritten as secant square x minus 1 into dx. Now you multiply. So integral tan power n minus 2x secant square x dx minus integral tan power n minus 2x dx. This is nothing but our I n minus 2. So you keep it as it is. Now this I can write it as tan power n minus 2 into, instead of secant square x, what can I write? Differentiation of tan x. So this is like integration of x power n into dx. What is integration of x power n into dx? X power n plus 1 by n plus 1, isn't it? So here it is tan power n minus 2x into d of tan x. So it will be tan power n minus 1x by n minus 1 minus I n minus 2. That's all. Okay, next. Similarly for cot power nx, integration of cot power nx dx, where n is a positive integer. The same procedure, differentiation of cot x is what? Minus cosecant square x. Now, so you rewrite cot power nx as cot power n minus 2x into cot square x. Rewrite cot square x as cosecant square x minus 1 and you multiply. So it will be cot power n minus 2 cosecant square x dx minus cot power n minus 2x. This is I n minus 2, and here this can be rewritten as cot power n minus 2 into differentiation of cot x. So this will be what? Minus cot power n minus 1x by cot n minus 1. Okay, then next one is integration of secant x power n dx, where n is a positive integer. See, for secant also you have to split the power by 2. So secant power n minus 2 into secant square, because differentiation of secant x is what? Secant x into tan x, right? But for writing the for doing the integration by parts, we need it in terms of secant square only. So secant power n minus 2 into secant square dx. Let us take this as u and this as dv, right? So u, that means what? du equal to n minus 2 into secant power n minus 3x into secant x tan x dx. That is chain rule I have applied here, right? Next, dv. From dv, v is equal to what? Secant square x integration is tan x, right? So n minus 2 into secant power, here it will be n minus 2x into tan x dx. Now you apply the formula. So what will be the formula? Integral in equal to secant power n minus 2x tan x minus integral tan x into n minus 2 into secant power n minus 2x into tan x dx. So it will be what? Secant power n minus 2x into tan square x dx. Again, I told you, no, new terms you should avoid within the integral sign. So tan square x should be removed. For that I am writing it as secant square x minus 1. First term is same, so just don't bother about it. Simplify only this integral. Write tan square as secant square 1 minus 1 and multiply inside. So secant power nx dx plus n minus 2 into secant power n minus 2x. So this is secant power n minus 2x into tan x minus n minus 2 into in plus n plus 2 into in minus 2. Bring in to the left hand side. So in into 1 plus n minus 2 is equal to secant power n minus 2x into tan x plus n minus 2 into in minus 2. So finally in equal to what? 1 by n minus 1 secant power n minus 2x into tan x plus n minus 2 by n minus 1 into in minus 2. In the same way, we have the procedure for cosecant power nx dx. Take in equal to integral cosecant x power n dx and split the term into cosecant power n minus 2 into cosecant square x. This is my u and this is my dv. So du equal to n minus 2 cosecant power n minus 3x into differentiation of cosecant x is what? Minus cosecant into cot x. by chain rule. Okay, then integration of dv, that is cosecant square x is what, minus cot x dx. So here it will be minus n minus 2 into cosecant power n minus 2x into cot x dx. Here it will be minus cot x. So in equal to minus cosecant power n minus 2x into cot x minus integral cot x into n minus 2 into cosecant power n minus 2x into cot x dx. So if you do the simplification as before, I am arriving at in equal to minus 1 by n minus 1 cosecant power n minus 2x cot x plus n minus 2 by n minus 1 into I n minus 2. Okay, that's all. Thank you.